Hello everyone, Aaron here. Welcome back to Leetcode. Today we are doing the average of levels in binary tree problem. Jumping right in, given the root of a binary tree, return the average value of the nodes on each level in the form of an array. Answers within 10 to the negative 5 of the actual answer will be accepted. Okay. Well, my immediate thought is to do something resembling a breadth first search through the tree. My second thought is this is an easy problem. That feels like like I've overwrought my solution already. The reason I'm thinking breadth first search is because effectively it goes through layer by layer. This layer, this layer, this layer, doing them one after the other. Is there some trick I don't know that would let me do this easier? The other thing I could do is just do any old traversal, keep track of what layer I'm in, and maintain a dictionary of lists that will let me compute the average for that layer. The dictionary option, I think, is definitely the one they're going for here. For an easy problem, all you do is you count what depth you're at, you go to the dictionary or even a list and say, right, I'm at depth 0, append a new value. The advantage the breadth first one has is it doesn't need to maintain anything like that. All you need to do is sort of work out when you're at the end of a layer, and then just compute the average of the preceding. Since you last computed the average, collect up the values and compute the average. So it's going to be much less memory intensive. So I think that's a more fun solution, actually. Let's do the breadth first search way. It's not the expected way, but it's a fun way. So I'm doing a breadth first search. I'm going to need to import the collection, so I have access to a deck. Let's do q is collection.deck, starting with a root. Is that capitalized? I can never remember if that's capitalized. I don't think it is. While q. Actually, let's do another one here. Let's also put in a none to say we're at the end of a layer. Actually, how do I want to do that? Let's do this. Let's do this slightly differently. I want to have the node and a boolean telling me whether it's the end of its row. Node end of row is q.pop left. Let's go in here and let's do a layer is empty, layer.append node.val if end of row result.append. Let's just do this average. What do we want? It says average. I guess that means mean. Mean layer is nothing. Then we want to do a q dot if node.left, so if I'm doing my breadth first search, I want to go left. If there's something there, q.append node.left and node. So this is the last thing in the layer. If the parent was the last thing in the layer, end of row, and it has no write node. If node.write, q append node.write, and this one is the end of the row. Well, only if its parent was the end of the row. It's a bit simpler than the left case. The left case is rarely the end of the row. The right case often will be the end of the row. I think that's basically it. I just haven't defined mean self layer returns sum layer over len layer. That's straightforward enough. Right, let's do a typo check. As always, I'll have made a dumb mistake somewhere. I have not made a dumb mistake somewhere. Excellent, we're off to a roaring start. Let's use all the example test cases. Ooh, made a mistake. What? I missed a layer. Oh, right. If layer result.append self.mean layer. Right. The reason I missed it there was because we never found where we thought the end was going to be. Because effectively the row ran out early. But all we needed to do there was check that, well, if we were halfway through a row, or halfway through a layer, then just make sure that we finish off that layer. Right, let's submit it. See how we did. Wrong answer. Ah! Oh, I know what it'll be. It will be a fun case of this, I think. Okay, let's stop trying to do it the clever way. Let's do it this way. Self.layers dictionary. Def recurse node and layer. If node is none, return layers. In fact, let's do a collection.default dict. Is that how that works? What's a default dict of a list? Layers.append node val. Layers layer dot append node dot val. Recurse node dot left layer +1. Recurse node dot right layer +1. Then it's for result is, let's do this. That should come out pretty much in order, shouldn't it? Yeah. For values in self.layers.values, the result is the empty list. Result append self.mean values. Result. The reason I paused for a second here was that the order these come out might be a bit funky. The other thing we could do is sort of count it as we go, but let's quickly run it and see if this works. I think these should come out in the right order. That's what it is. Default dict. I was wrong both times. I refuse to subscribe to this. Wrong answer. Wrong output. Oh, I didn't actually do it. Recurse on the root with depth 0. Fixing typos. There we go. That's better. Right. This time. Perfect. Not the fastest. Not the most memory, but not the least memory, but it worked fine. I think there's something in that breadth first search approach. It's just I can't quite work out. I think it's basically if you have a fully left branching tree, like if it's just a chain going left, you're going to end up with weirdness there and other cases related to that. So that's going to stop the breadth first search working. You need to remember somehow that basically there's a problem there. Okay. This worked. Anyway, this worked. So stop fretting over a solution that didn't work. Let's just do the obvious thing. Right. That's it for this week, of course. I hope you had a good week, and do remember to like, comment, subscribe, all that good stuff. It is really helping the channel. We are getting more views, and I really appreciate all of you out there who are watching, liking, commenting. Thank you so much. Anyway, have a good weekend, and I will see you next time. Bye.